Okay, so we are going to start this paper. We're going to try and solve 0620, paper 4.2. This is IGCSE chemistry paper, paper 4. It's the theory paper, the extended version. So let's start by solving this question. The first question is you're being asked to name eight substances are given. So eight substances are provided, and what's given is you're being asked. Eight, all of them are different compounds. The first question is which is the main substituent of natural gas, and that is methane, which is given or provided over here. Methane is CH4, so we'll write methane. So that's done. The next one is a reactant in respiration. So respiration is going to be oxygen gas. Oxygen gas is the main reactant in respiration. And I'm going to explain to you what respiration is. Respiration is where your cells produce energy. They take glucose, C6H12O6, and they react it with O2 to produce carbon dioxide and a water molecule. So you can balance this equation. It would be six. Everything would be six, and this is the balanced equation for respiration. The equation for photosynthesis is exactly the opposite. The next one is the main constituent of bauxite. Bauxite is the ore which contains aluminium oxide. You're going to extract aluminium from it, so AlO3 or aluminium oxide. And the next one is a product of synthesis, photosynthesis. The product of photosynthesis is uh, this is the opposite. If you read this equation in the backward direction, that is going to be uh, photosynthesis. So the product of photosynthesis is either glucose or oxygen gas. So the product of photosynthesis is going to be oxygen gas as well. So that's being repeated. And the next part is a greenhouse gas. A greenhouse gas is one that causes global warming. So how many gases? Methane is your greenhouse gas. It absorbs a lot of heat that leads to the melting of glaciers and unpredictable weather patterns and the rising of sea levels. So methane gas is one key component of greenhouse gas. Carbon dioxide is another one. So it's CH4 or methane. And then the next part is a macromolecular solid. That one, a macromolecular or giant covalent structure is silicon 4 oxide, SiO2. The structure of SiO2 is that it is, if I draw the structure of SiO2, it's a silicon bonded to four oxygen atoms in a tetrahedral arrangement. So this is the three-dimensional structure. And then the oxygens are further bonded to silicon. And then the silicon is further bonded to oxygens, and the structure just keeps on repeating. So the same thing over and over keeps on repeating. Each silicon atom is bonded to four oxygen atoms, and each oxygen atom is then again bonded to silicon, and then that is again bonded to four oxygen atoms. SiO2 is a macromolecular or giant structure. This is basically your sand. So silicon 4 oxide. The next part of the question, let's move to question number two, which is it has sodium, three isotopes of sodium. Describe how these sodium isotopes are the same and how they are different in terms of the total number of protons, neutrons, and electrons in each. So this one is an easy one. What is an isotope? An isotope is are atoms that have the same proton numbers and electron numbers and electrons as well. The only thing that's different is the number of neutrons. So they have pretty much the same chemical properties because chemical properties they depend on the number of protons and the number of electrons. Neutrons really don't attract anyone, so they're not involved in bonding, so they don't affect the chemical properties. Why do all three isotopes have an overall charge of zero? The reason they have an overall charge of zero is they have the same or equal number of protons and electrons. Protons are positively charged particles, electrons are negatively charged particles. So overall, the charge is going to be zero because they're going to balance each other out. Why do all three isotopes have the same chemical properties? Because they have the same electronic structure. They have the same number of electrons. So they have the same electronic configuration. So they're going to bond in exactly the same way. Why do sodium ions have a positive one charge? So they have a positive one charge because they have exactly one valence electron, and they lose that one valence electron. So they are group one. Now group ones are going to have the same. All of them are going to have a plus one charge. Next part is that carbon is an element which exists in different forms. Name two forms of the element carbon that have a giant covalent structure. So two forms. Remember carbon? It's graphite, and the other one is diamond. So there are two forms or two allotropes of carbon, um, different physical forms of the same element. Graphite is what's the structure of graphite? Just a quick revision. In graphite, each carbon atom is bonded to three carbon atoms, and in it, the fourth electron gets delocalized. So each of the carbon atom is bonded to just three carbon atoms, and the structure just keeps on repeating. And it's a sheet-like structure. So they're going to be sheets. So this is the structure of graphite. It just continues. It's a single sheet. A single sheet is called graphene, but it's an endless giant covalent structure. And there will be multiple sheets right on top of one another. So, and the sheets are going to have van der Waals forces. So if you think of them as these sheets, if I have a sideways view, the sheets are going to have these weak van der Waals forces. They're going to have these weak van der Waals forces between them. So graphite is a very good conductor of electricity. There's a delocalized electron because the fourth electron in graphite, in carbon, is not bonding. It's available for electricity conduction. The other one is diamond. In diamond, in the structure of diamond, carbon is actually just like SiO2. It's making four bonds with four other carbon atoms. So all electrons are used. It's not going to conduct electricity, and it's going to be a very, very strong structure because it's going to be an endless structure where each carbon atom would be making four bonds with four other carbon atoms. So it's going to be an endless structure. It just goes on and on. It's a very strong structure. It's a very hard material and it's used for cutting and as an abrasive. Whereas graphite over here is a very, very soft substance because the sheets of graphite are going to have very weak van der Waals forces. So it's going to be very slippery. The melting points are high because you have to break a lot of bonds, but the sheets, each sheet, each individual sheet, think of a page of copy, a copy full of pages. The pages can slide over one another. So graphite is going to be something similar. Now, name the next part is name the oxide of carbon that is a toxic gas. So the oxide of carbon that's a toxic gas is carbon monoxide. Why is it toxic? Remember, carbon dioxide has no issues. We are breathing out carbon dioxide all the time. So carbon dioxide is absolutely fine, except that it's a global warming. It causes global warming. But carbon monoxide is toxic, poisonous. It attaches to your red blood cells and causes choking. People can die from carbon monoxide poisoning because your red blood cells, it goes and binds with them, and the red blood cells are not able to carry oxygen if carbon monoxide is present and you're breathing in carbon monoxide. Let's move to question number 3 now. Now, question number 3 is the question is about phosphorus and and compounds of phosphorus. Phosphorus has the formula P4. Some properties of P4 are shown. So the melting and boiling points are really not very high. It's a non-conductor and it's insoluble. Name the type of bonding that exists between the atoms in a P4 molecule. So based on these properties, it's going to be a simple covalent molecule. Low melting points and a non-conductor, which means, and it's a non-metal as well. So it's going to be a simple covalent molecule. If it had been a giant covalent structure, the melting and boiling points would have been much higher. The next part of the question is explain in terms of attractive forces between particles why it has a low melting point. They are weak. There are weak intermolecular forces. There are weak intermolecular forces between present uh, between P4 molecules. That's always the case. So if you have one P4 molecule and you have another P4 molecule, they're not going to have a bond between them, and they're going to be attracting each other very weakly. The next part is why is it a non-conductor of electricity? Because it's a covalent molecule. They're sharing electrons. All the electrons are occupied. So it's a non-conductor. Why? Because there are no free-moving electrons or ions are present. So it's a non-conductor. The next part is it reacts with air to produce phosphorus oxide, and we are being asked to give an equation. So air is the reactive element in air is oxygen. So it's P4 plus O2, and it's going to form P4O10. So P4O10 is going to be formed, and we need to balance this. So P4 is balanced. This would be 5O2, so that I can have 10 oxygens. What type of chemical reaction is this? Now, based on this, it's going to be a redox reaction, or you can call it an oxidation reaction because oxygen is getting added up. So if oxygen gets added, it is called oxidation. The next part of the question is phosphorus. P4O10 is an acidic oxide, reacts with aqueous NaOH to form a salt containing the phosphate ion. What is the only other product? Write a chemical equation for the reaction between phosphorus 5 oxide, so it's P4O10, and the other thing is sodium hydroxide, NaOH. And then they said that water is the only other product. So let's add in water as well. So let me write the reaction. It's going to be P4O10 specifically, plus it's going to be NaOH. And the product that's going to be formed is going to be what's going to be formed is water is the only product. So they're already talking about somewhere over here. Water is the only other product, and there's going to be a salt that contains phosphate ion, a salt containing phosphate ion. The only salt that's possible is sodium phosphate. So Na is +1, PO4 is -3. So we're going to form that salt. It's going to become Na3PO4, and we need to balance this equation. So to balance this equation, there's P4. So there should be four P's over here. So the whole entire this compound is going to be multiplied by 4. That gives me 12 sodium. So I'm going to add 12 sodiums. That gives me 12 hydrogens. So it's going to be 6 water molecules. And the last element should be balanced on its own. It should be. We can count that oxygen is 10 and there are 12 oxygens over here. So that's a total of 22 oxygens. This is 16 oxygens. And on the other side, you have 6 oxygens. So that's 22 as well. Now, the next part, moving to the next part of the question. Now, the next part, moving to the next part. You're given phosphine pH 3. That's given. Complete the dot and cross diagram to show the electronic arrangement in a molecule of phosphine showing outer electrons only. Phosphine is in group 5, so group 5 needs 3 electrons. It ends up sharing 3 electrons with 3 of the hydrogens, and hydrogen shares an electron back. So in group 5, so it shares 3 electrons. There are 2 electrons still left. So that's the molecule of phosphine. Phosphine has a similar chemical structure to ammonia. Ammonia acts as a base when it reacts with sulfuric acid. So, what is meant by the term base? Base means proton acceptor. or H plus one. What's a proton? It's an H plus one acceptor. Remember, acid is a proton donor, base is a proton acceptor. You're being asked to write a chemical equation, a reaction between ammonia and sulfuric acid. So we'll do that. It's going to be NH3 plus sulfuric acid. So when ammonia is a base, it acts as a base, it reacts with sulfuric acid. How is the salt produced? This H is going to get substituted by ammonium. So NH4 plus 1 is going to take its place. SO4 remains there, it's minus 2. And if I make the formula use crisscross, it's going to be NH4 twice SO4. And I need to balance this. Remember, don't you can rub off the charges. If I balance this, it should be 2NH3. So whenever ammonia reacts with an acid, it produces ammonium salt. Any acid, it's going to be the same thing. Let's say ammonia reacts with hydrochloric acid, HCl. Then the same thing, the salt would be produced. Ammonium is going to take its place. It's going to be NH4 plus 1 and Cl is minus 1. So no crisscross required over here. So you can do this with any other acid. Any acid, if it reacts with ammonia, it produces ammonium salt. Let's move to the next part of the question, which is that methanol. Now, this is probably about equilibrium. Methanol is made industrially by reacting carbon monoxide with hydrogen. The gases react at a temperature of 250 and a pressure of 75 atmospheres. The forward reaction is exo. So I'm just going to write it over here so that we remember this. The forward reaction is exothermic. It's exo in the forward. Suggest a source for the industrial an industrial source for hydrogen. There are two sources. One is water, the electrolysis of water. So that's one way of producing hydrogen gas. The other one is cracking of oil. So that's the other one. The next part is complete the table by using the words increases, decreases, or no change, adding a catalyst effect on the rate. Now, whenever you add a catalyst, rate is going to increase. It lowers activation energy. It speeds up the reaction. Uh, the other part is about equilibrium, no change. Why no change? Because at equilibrium, adding a catalyst increases the speed of the forward reaction as well as the speed of the backward reaction. So if 1,000 molecules are being produced in the forward direction, 1,000 molecules are being produced in the backward direction, the net result is going to be the same. Increasing temperature, the rate increases. Why? Because you have more kinetic energy. Now, increasing temperature favors which reaction? It favors the endothermic reaction. So endothermic, remember the forward reaction was already, we already knew that the forward is exo. Going in the forward direction, the reaction is exo. It's going to be the backward reaction, which is going to be endo. So the backward reaction is endo. That indicates that increasing temperature is going to produce, it's going to have more, you're going to get more backward reaction. And if you're going to get more backward reaction, the amount of methanol that you have at equilibrium is going to be lesser. It's going to decrease. So backward reaction is favored. Hence, the amount of methanol it decreases. Next one is decreasing pressure. Now, whenever you decrease pressure, the rule is Le Chattel principle states that whenever you decrease pressure, more gas mole side is favored. So more gas mole side is going to be it's going to be favored. Now, if more gas mole side is favored, then again it's going to be the backward direction because the first forward reaction produces lesser gas, the backward reaction produces more gas. So more backward effect on rate. Decreasing pressure. Let me talk about equilibrium first. So it's going to decrease again. And why is it decreasing? Because you're getting more backward reaction. What about pressure? Decreasing pressure increases volume. So particles are further apart, so less frequent collision, so the rate would be slower. So it's going to be lesser as well, decreases. The next part of the question is state two general characteristics of homologous series. That's how you classify organic compounds. So they have the same general formula. And one more thing, which is so they have the same general formula, and the other thing is they have the same functional group. Like all alkenes have, so they have the same functional group as well. So all alkenes are going to have the carbon double bond carbon. All alcohols are going to have OH group. So the functional groups are the same as well. Let's move to the next part, which is draw the structure of two different alcohols, each containing three carbon atoms. Show all of the atoms and all of the bonds, and name these two alcohols. So I'm going to draw these two alcohols, three carbon atoms. So that's one, two, three. An alcohol is going to have an OH, and I'm going to add all the hydrogens. So we have all these hydrogens added. Another alcohol with three carbon atom could be that the OH is on the middle carbon atom, and I'm going to add in all the hydrogens again. Now, one of them is both of them are prop, which means three carbon atoms. This one is propan one all. One indicating that the OH is at position number one, and this one is propan 2 all, which means that the OH is on position carbon number, the second carbon atom. So one is propan 1 all, the other one is propan 2 all. Let's move to the next part of the question, which is what term is used to describe compounds with the same molecular formula but different structural formula? And that is the term isomers. Then the next one is alcohols react with carboxylic acid to produce esters. The structure of an ester is given. So all esters have this functional group C double bond O. And so this is your ester functional group. And we are supposed to name this ester. Esters are named in two parts around the ester functional group. This side has one carbon atom, so this would be called meth. This other side has two carbon atoms, so that would be called eth. The names are going to end differently. The suffix is going to be different. The single O side is going to be called ethyl, whereas the double bond O side would be called O8. So the name of the molecule would be ethyl methanoate. So it's going to be ethyl methanoate. You're being asked give the name of the carboxylic acid and the alcohol that react together to produce ester X. So this side is the alcohol side. This came from the alcohol. This had OH over here before it joined. So this is two carbon atoms. It's an ethanol molecule. The ethanol is going to come in and then lose its H. This other side is the carboxylic acid side. Before joining, it was C double bond O and OH. So it has one carbon atom. So this is the methanoic acid, the carboxylic acid, methanoic acid side. So the name of carboxylic acid and the name of the alcohol have been given above. I've mentioned that. I've mentioned those. The other part is ester Y is different from ester X, but it also has the formula C3H6O2. Draw the structure of ester Y showing all atoms. So what I need to do is I need to make another ester that has the same molecular formula, same number of atoms. What I'm simply going to do is that this side had one carbon atom, this side had two carbon atoms. I'm going to flip that. I'm going to have two carbon atoms on this side and one carbon atom on this side over here. So I'm going to take the ester link. So previously there was only one carbon atom over here and two on the other side. Now one on that side and two on this side. So I can come up with another type of ester. And this side has three hydrogens. So I can come up with another type of ester, and they're not asking me to name this, so I'm not going to name this. Let's move to the next part, which is question number 5. In question number 5, you're given that copper sulfate dot 5H2O are hydrated, and the crystals, and there's an equation given. The reaction is happening. Powdered solid copper carbonate is added to 50 cm³ of sulfuric acid. Copper carbonate is in excess, so I'm going to write that down. This over here is in excess, and I can find the moles of this. The volume and concentration is given, so let's. Why don't we try and find the moles? It's 50 into point concentration into volume is moles. So it's 0.05 multiplied by 50. So here's my calculator. So 0.05, multiply that by 50. And then I need to divide that by 1000 because it should be in dm cube. So I get 0.0025 moles. So let's go back. So that means the sulfuric acid that's being added is 0.0025 moles. So that's the amount of sulfuric acid that's being added. Then the excess of copper carbonate is separated from the copper sulfate. The copper sulfate is heated until the solution is saturated. Now, the moles of sulfuric acid, the moles of copper sulfate are going to be exactly the same because the equation is 1:1. So that indicates these two would have exactly the same moles. So I'm going to find those moles as well, 0.0025 moles of copper sulfate dot 5H2O are going to be produced. The solution is allowed to cool and crystallize. The crystals are removed and dried. Calculate the maximum mass of copper sulfate that can form using the following steps. Now we've pretty much done all the steps. I don't need the steps. I just need to figure out the mass now. That's the last step. How do you find mass? Mass can be found by multiplying the moles by the MR. So it's 0.025 moles or 0.0025 moles. So it's 0.0025 moles. And I need to find out the MR, which is hopefully it is given somewhere. They've given us all the steps. The MR of copper sulfate is also provided. That's given as 250. So let's do the working on the question. So it's given as 250. So it's going to be 250 multiplied by the thing that we had, 0.0025 moles. And I need to multiply that by. So I need to multiply 0.0025 with what? I need to multiply it by 250. So let's multiply it by 250. And I get 0.625 grams. So the final answer is 0.625 grams. Remember, all the working has been done on the question. So all the steps have been done, have been performed. The first step was calculate the moles of H2SO4, which we did. We found 0.0025 moles. Then they asked us to, in the next step, they asked us to figure out the moles of copper sulfate. So they were going to be the same because it had the same ratio. And then we had to figure out the mass. So I multiplied it by the MR. Anyways, let's move to the next question. The question is steps 1, 5 were done correctly, but the mass of crystals obtained was less than the maximum mass. So explain why. Lots of reasons for that. Uh, so why were you getting less crystals than the mass that has been calculated? So a number of reasons for that, and that could be one of them would be that the concentration or the moles of sulfuric acid were calculated incorrectly, or there were impurities present. So I'll just go with impurities. You can check the marking scheme for this one. So explain why impurities are present, so your solutions are not pure. Or you could have said another thing that could have been stated was that copper sulfate is soluble. Some of the crystals might still be dissolved. So some of the crystals might still be dissolved in the solution. Might still be dissolved, and they probably did not crystallize. Anyways, the next part is state two observations that would indicate that the copper carbonate was in excess. So copper carbonate remains at the end. So it's probably remaining unreacted at the end. The other thing is that the bubbles of gas would stop forming because copper carbonate adding copper carbonate uh, is going to produce carbon dioxide gas. So bubbles or effervescence stops producing. The next part of the question is when the reaction in step one is done, using lumps of copper carbonate instead of powder, the rate of the reaction decreases. All other conditions are kept the same. Give a reason. So, so large lumps have because if you have a large lump, only the outer particles are the ones that would be able to take part in the reaction. I mean, these arrows, sulfuric acid surrounding it, and this is your calcium carbonate. So large lumps have lesser surface area. The inner particles would not be able to react. Large lumps have smaller surface area. So less frequent collisions happen. Then you have name a different substance other than copper 2 carbonate that could be added to dilute sulfuric acid to produce copper sulfate. Remember H2SO4, that's an acid base reaction. You could have an acid base reaction like copper oxide can be added and it would still form copper sulfate plus water molecules. So there are other things. You can't add a metal. Metal plus acid wouldn't work for this because copper metal is a very unreactive metal, so it's not going to react with it. So it's either metal oxide or hydroxides or metal carbonates. Name the process used to separate aqueous from the excess of copper carbonate. So copper carbonate is insoluble, so you can use filtration to get rid of the copper carbonate. The solution of aqueous copper sulfate was heated until it was saturated. Suggests what is meant by the term saturated solution. So saturated solution is the one where excess solute particles excess solute particles are present and now crystallization is possible.